today we are going to discuss class 6 NCERT line by line. Okay, so this will help you to understood the topic very clearly. So let's start the chapter, and I'll request you everybody, please keep a note of all the important points that we are discussing here. So we'll discuss line by line. Chapter 4, exploring the magnets. Resma lives in a coastal town of Kerala and is very fond of writing short stories. Her grandmother loves listening to her stories, so Resma was writing a new story to share with her grandmother on her 60th birthday. ओके, तो अब तक कहानी में क्या है कि जो रेशमा है वो उसको राइटिंग लिखना बहुत पसंद होता है, तो वो अपने दादी के लिए एक स्टोरी लिख रही है. अब स्टोरी में क्या कहानी है? नेक्स्ट, द स्टोरी वाज बेस्ड अपॉन अ शिप carrying spices from Kerala for the trade in the old days. So here you will get one information that the Kerala is famous for spices, and it is also known as the spice garden of India. Next, Reshma was aware that in those days the sailors, just mark the word sailors used stars to find the direction at night. Okay, here the words are very important, that one is sailor, stars, and direction at the night. So direction we need to find. But in her story, a situation crossed wherein the sailor get caught in a storm with an overcast sky and stars were not visible. So in this case, listen, very simple, that old days people used stars to find the direction. Okay, suppose that the stars are not visible, then the question arises that how to find the direction. How to find direction? This question should arise in your mind. Resma could not take her stories forward as she could not think of a way for the sailors to find the direction. Now she has to stop his story. Why, sir? Because she is not able to explain how to find the direction when there is no star. अगर stars नहीं visible हैं, तो how to find the direction? How to find the direction? Now, so she searched for the information on the internet and her school library. She learned that the travelers used a device. Just here the main things are coming. A travelers used device known as magnetic compass for finding the direction. Very, very important. Just mark this line. Travelers used a device known as magnetic compass for finding the direction. So here we have learned one thing, that to find the direction we need a magnetic compass. Later in the chapter we'll discuss about what is magnetic compass is and how it works. Okay, so next, Resma had a pencil box and a purse which had magnets to keep them closed. So we have seen several items where the buttons are actually magnets. Writing boards in her school, also a duster with a magnet. Just mark all the things. Okay, but she had never looked at those carefully, so she now become curious to learn more about magnets and magnetic compass. So here basically the idea is that in this chapter we'll mostly discuss about magnets and magnetic compass, okay, and how we can use them in our real life This is important. Okay, and the curious, the book name is Curious, so it will explain you the concept of magnets and magnetic compass. Okay, so for your information, this device is nothing but a magnetic compass. It's a magnetic compass in which we can see that it is written here North Pole, this one is your South Pole, this is your West, this is your East. It is marking here, and this one is Northeast. You can just see here, this one is Southeast, this one is Southwest, and this is Northwest. Okay, so these are the directions, 8 directions will use in this compass to find the direction. Next, so just you can see here several items are given. Just look at these items. This is a box full with pins. Okay, this is your duster, this is a mobile cover with, here it is a pouch, I think a magnet, a pencil box with a magnet, a door closure with a magnet, and these are basically freeze magnets. So here in all these cases we use simple magnets, we use magnets to close them all. So some common items that have magnets attached to them. Now the magnets closed by the sailors in the old days were used based on naturally occurring magnets are known as lodestone. So what is lodestone? Lodestone is basically a natural occurring magnet. What is lodestone? Lodestone is a natural occurring magnet, is known as lodestone, and which was discovered in ancient time. It is discovered in ancient time Greece. Okay, you know the country name Greece. Greece, it is in country Greece it is discovered. Okay, now later on the people found that magnet could also be made from the piece of iron. Okay, here we'll discuss how to make magnets from piece of iron. Nowadays we have magnet made of different materials. Okay, first in ancient time we used lodestone as a natural magnet. Now we are using piece of iron made magnet and different material as well. Now the magnet that you found in your school laboratory and those used in pencil boxes, stickers, toys, and all are artificial magnets. So here we have one more thing. First one is natural occurring magnet, and the second word that we will discuss here is artificial magnets. Artificial magnets are very important. Okay, why they are important we'll discuss. We'll discuss in detail. Okay, artificial magnets, all these are artificial magnets, that is pins, board, this is box closer, door closer, freeze magnets. All these are example of artificial magnets. The magnet can be of various shape as well, of some of which we are shown here. Okay, here just you know that magnets can have different shapes. Okay, now so you can just see we have different types of shape of magnet. First one is a bar magnet. It just look like a bar. So what is bar? Bar means rectangular shaped magnet. Basically it is shape of rectangle. Okay, just rectangle, you know. Bar shop means which has a rectangle shape. Okay, and now U shape, it is look like a U, so it is a U shaped magnet, and also a ring shaped magnet. Okay, so one question for you: do magnets stick to the object made of certain material only? So what is the answer here? Listen, these questions can be answered by you after discussing the chapter, that do magnets stick to the object made of certain material only? So question is that yes. Question is yes. Answer is yes. Magnet only attract to certain materials, like you can say here iron, Fe, nickel and cobalt. Okay, cobalt. These are the basic materials of which magnet can attract. Okay, so different steps that we have discussed, the question we have discussed. If you know the more about this, just comment below down. Now, so we will discuss next activity. Will discuss magnetic and non-magnetic materials. Will discuss in detail. So get ready. Listen. Here, activity 4.1. Be careful whenever we discuss the activity. Be very careful. Be very careful. Okay. So what is the activity here? First, collect a few objects made of different materials and also a magnet. So what you need? You need different materials with a magnet. Why it is magnet? Why we require this? Because magnet will attract the materials. Okay, now predict. What is predict? Just guess which of these objects will stick to the magnet. Write your prediction in the table 4.1 given below. So we have the table below. We just need to write down yes or no. Yes for those will attracted to the magnet, or no for those will not attracted by the magnet. Now hold a magnet in your hand and bring it near an object one by one. Just keep a magnet. Suppose that you have bars with magnet, so and just bring materials near this. Suppose that. So if it is attracted, then it is magnetic material. If it is not attracted, then it will be must non-magnetic. Okay, if it is not attracted, then it must be non-magnetic. Okay, now observe which of the objects stick to the magnet. If they stick to the magnet, then they are basically magnetic materials. So here we have collected some samples for the explanation. Samples. This is a cardboard. Made of wood. These are the nail made of basically iron ore, paper, some paper clips. This is wire, but it is coated wire. Just see there. Key made of iron. You can see that. Okay, key. This is sharpener, and this material is made of iron. Some nails. One is matchbox. Color pencil. Glass, scissors. You just see this part. Candle made of wax. Pencil made of plastic. Stapler, just see this material made of metal. Pencil and cloth you can see here. And now just this is the activity. This is the magnet. You need to bring one by one all the objects. So identify the materials attracted by a magnet. So from here, okay, listen. This is made of wood, so it will not attract it. So we'll just write here N for no. Iron made of yes will attract by the magnet. This one is a paper, so it is no. Iron clips, yes. Wire, maybe yes. Nail, yes. Sharpener, yes. Why it is yes? Because this material is made of iron. Nails, yes. Matchbox, no. Pencil, we can say here no. Glass, no. Scissors, yes, because this part is made of metals. Candle, you can say no. No. Ruler, no. Stapler, yes, we can say yes. Pencil, no. Cloth, no. Okay, so we have discussed all the things. Now we need to make a table. Here, just see this table. Now so record your observation in the table. This one. Okay, so first one is name of the object. Suppose It is given here pencil. It is given here pencil. So material which the object is made of. So we have taken here pencil. So pencil is made of what? Wood. Attracted by the magnet, yes or no? So answer is prediction. मान लो मैंने कहा था कि yes हो सकता था, but what is observation? No. Eraser made of rubber, yes, and prediction is about that no, will get the answer no. Eraser will not attracted by the magnet. Suppose that I am writing here paper. Okay, paper I am writing here. So paper is made of wood, and again the answer is no. Okay, suppose next one is your nails. So nails is made of basically iron. So our prediction is that yes, it will attract. Answer is yes. So like this you will just complete this activity, and finally what you will conclude from this activity. Okay, after completing this activity, what is the result? So was your prediction correct for all the objects? Listen, if you are predicting something, then your answer will be yes, sometime no. Both will be possible. Which material stuck to the magnet? Question is that which material stuck to the magnet? What conclusion can you draw from this activity? So here the answers are, through this activity we found that some of the objects were attracted to the magnet and stuck to it. Some materials attracted to the magnet, while others were not. The material here, this is the thing, the material which are attracted towards a magnet are called magnetic materials. Here very simple definition is that the material which are attracted towards the magnets are known as magnetic material. And for example, it is made of metal iron, yes, is a magnetic material. Nickel and cobalt are often metals that are also magnetic. So we have already I've told you that one is iron, nickel and cobalt. These are the materials that are used as magnetic materials. Some of the other combinations with other metals are also attracted towards the magnet. The material which are not attracted towards the magnet are called non-magnetic materials. So what are the non-magnetic materials? Which are not attracted towards the magnet. Okay. So next we'll discuss, a question is here, very important. Do all the parts of magnet attract magnetic materials equally? Question क्या है कि क्या magnet का हर एक part, like this is the part of magnet, so the materials which listed here were found to be non-magnetic. Okay, so next, so question is that we have seen the question that which part of magnet will attract the most, or is that all the parts of magnet attract or have the same strength to attract the materials? The question is no. Sorry, the answer is no. All the parts of magnet not have the same strength to attract the materials. So how to discuss it? Okay, so let's do an activity. Activity number 4.2. The poles of magnet. The poles of magnet. So what are the poles? As we know that, suppose that we have the earth. Okay, everybody knows that the earth. So you know that earth has the two poles. One is north pole, one is south pole. Everybody knows that Earth with the two poles, South Pole and the North Pole. So now discuss. Just keep in mind that we have the two poles, South Pole and North Pole. Now discuss here. Activity 4.2. Let's investigate. Spread some iron filings, very small piece of iron on a sheet of paper. So what is the meaning of iron filings? Iron filings are the materials which are very small size piece of iron. Okay, basically. Now place a bar magnet over them. What is bar magnet? We have discussed already. Bar magnet means a rectangular shaped magnet. Bar magnet means a rectangular shaped magnet. Okay. Now tap the paper and observe carefully what happened to the iron filings. Tap the papers and just observe what is happening with here. Do you observe something special about the way they stick to the magnet? Okay, just need one thing. You need to be very careful about, do the iron filings stick all over the magnet? Question is that, do the iron filings stick all over the magnet uniformly? Okay. Or do the iron filings stick more at some places? We will find that here. You can just see the diagram. I'm just going to explain. Just see this diagram. Okay. In this diagram, we can clearly see that at this region, at the corners, at the extreme corners, the iron filings are attracted, stick mostly, and in this region, minimum. So here, max, here, min. So here, max. So we have the two places where the attraction is maximum. One is this side, other is this side. Now, so we found that maximum iron filings stick near the ends of the bar magnet, as shown in the figure. So ends of the magnet. Remember that, ends of the magnet. If this is a magnet, this is the magnet. So these are known as ends. These are known as ends of the magnet. Sorry. While a very few iron filings stick at the remaining part of the magnet. So here, what we conclude from this activity, if we repeat this activity with the magnets of other shape, do we get the same amount result? The answer is yes, we will get the same result. So what we have learned here in this activity, we have learned one thing, that a magnet has two poles. One is South Pole, other is North Pole, and one thing, at the corners of the magnet, the strength or the attraction is maximum. The attraction is maximum. The attraction is maximum at the corner. So we have decided the two poles. A magnet has two poles. One is South Pole, other is North Pole. So how to define South Pole and how to define North Pole? How to define South Pole? How to define North Pole? Okay. So these ends of the magnets are called two poles of the magnet. So we have discussed the ends of magnets are called poles. One is the North Pole and other is the South Pole. Now, how to define North Pole and South Pole? Most of the iron filings stick to the poles of the magnet of any shape that we have discussed already. If the iron is of any shape, that is, if it is U shape, if it is ring shape, always remember that at the poles attraction will be maximum. It is not possible to obtain a magnet with a single pole. Listen, this is very important. Suppose that you have a magnet like this, and this is North Pole, suppose South Pole. If I break this magnet in the two pieces, then it will become like this. Okay. So if this is South Pole, then there will be North Pole, and this is North Pole, This will be south pole. So magnet cannot be exist in a single pole. Single pole magnets cannot exist. We can define a magnet with a single pole. Answer is no. We cannot found a magnet with a single pole. Very, very important thing. We cannot found a magnet with a single pole. We cannot find a magnet with a single pole. Okay, this is the question. Now, if a magnet is broken into two small pieces, north pole and south pole always exist in pairs in the smallest piece of the magnet. So a single north pole or single south pole cannot exist. Then we ask the question, this question. When we found a magnet be a single pole, answer is no, and we will just explain these things. That if a magnet is broken into smaller pieces, north pole and the south pole always exist in pair. We will write north pole and south pole always exist in pair even in the smallest piece of the magnet. So a single north pole or single south pole cannot exist in a magnet. Okay, this is the activity 4.2 explanation, and here we have discussed very clearly that magnet has two poles. One is south pole, other is north pole. It cannot have a single pole. It always exists in pairs. It must be have south pole and north pole as well. Okay, now we'll discuss the things. So we have just remembered the story. What is the story that Reshma want to give? Reshma is going to discuss directions that we have already discussed. कि Reshma को क्या चाहिए था? उसको चाहिए था direction. So now finally we reach at our curiosity level कि अब हम direction पता करने वाले हैं. So to explain this activity, we'll discuss the activity number 4.3. So what is the 4.3 activity? Just see then this setup. Suspend a bar magnet with a thread to the middle of a magnet shown in the figure. Okay, just take a bar magnet, tied it with the string, and just hang up like this. Now, to adjust the position of the string till the magnet is balanced horizontally. Okay, so you just remember that. Be careful that magnet should be horizontally. It should be horizontally. Okay, it should be horizontally. Why? You just feel the answer why it is. Why? Just we are going to discuss why. So you will just mark the word horizontally. Now, rotate the magnet gently in the horizontal direction and let it come to rest. Just disturb it once. Rotate this magnet in the horizontal direction as well. Now wait till it come to rest again. Now mark the position corresponding to the ends of the magnet on the ground. Okay, ground page, just mark the position. Suppose that this side it is north, this side it must be south, this side it is west, this side it is east. So on the ground we will just mark this scenario. Okay, now, and join these 2 points on the ground with the line. Suppose they mark this point A, point B. So just join them, these 2 points. Next, this line indicates the direction along which the magnet come to rest. So this is the direction of the magnet. So I think Reshma will get the answer. Okay, now again rotate the magnet by giving a gentle push at its one end and wait till it come to rest for the next step. Does the magnet again along the same line? So the answer will be yes. by the observation we can say that this time also it will align, and this time it also align to the same position. So from this activity what we can conclude? We conclude that magnet always align towards north south direction. It is always aligned towards north south direction. So this is known as the directive principle or directive property of magnet. We call it a directive property of magnet. Okay, just remember this word magnet. Now here we have some questions that what direction does this line indicate along which the magnet resets? How can we find it out? So what direction? This is north south direction. And how can we find it? You just know that the rising of sun is towards east, so this will be west, this side is north, this side is south. We will see that it is always aligned towards north south direction. Okay, if we have noticed the directions where the sun rises or sunset. So sun rises means what? Just comment below. Sun rises is in the east direction and sunset in the west direction. We have an approximate idea of where east or west is. Hence, we can locate the direction of or along which the magnet resets. Okay, so I've just explained. If this side is east, this will be west. So this will be your north, and this will be your south. Left hand is your north, right hand is your south. So this is the activity now. So what we have learned from this activity? What is the outcome of this activity? Remember that a freely suspended magnet come to rest along the north-south direction. Very important. A freely suspended magnet come to rest along the north-south direction, and the ends of magnet that pointed towards the north is basically north-seeking pole or the north pole of the magnet. Okay, north pole of the magnet. Magnet always comes along north-south direction. Then the north pole is towards the north of the earth, so it is north pole, and the south pole is towards the south of the earth, that is south pole. Now the other ends that points towards the south direction is called south seeking pole or south pole of the magnet. जो pole south में उसको south pole बोल सकते हैं बेटा. So this is the scenario, and so finally what we give the answer? We give the answer as a freely suspended magnet rests along north-south direction because our earth itself behaves as like a magnet or giant magnet. Okay, what we have discussed, a freely suspended magnet always aligned towards north-south direction. And what is the reason? The reason is that because we consider earth as a magnet. If it is a magnet, then north and south will attract. So it will be one pole, one pair, south north, again one pair. Now we need to repeat this activity again. Repeat this activity with a small iron bar in place of a bar magnet. So we can repeat this activity with a small iron bar instead of a bar magnet. What do you observe here? Does it always rest along the north-south direction? The answer is yes. It does not. Okay, it does not. Okay, it does not. So it can reset or rest along any direction. This implies that only magnets resets along north-south direction. This activity provides us with a way to test whether a piece of metal is a magnet or not. Listen, what we have what is the importance of this activity? If you take a small iron bar, it is not the magnet, it is the iron bar only. So when we place, so we can see that it will not align towards north-south direction. So if material is not aligned towards north-south direction, we simply conclude that not a magnet. It is not a magnet. So we can explain which material is magnet or which not by this property of magnet, that if it is aligned towards north-south direction, it is magnet. If it is not, then it is not a magnet. The property of a freely suspended magnet always rests along the north-south direction is used to find direction. So we got our answer that the property of a freely suspended magnet to always rest along the direction north-south direction is used to find the direction. So this property is used to find direction. So Resma will get its answer. So she can use a bar magnet to find the direction in the ship and used by the sailors. So from this activity we can conclude that when a freely suspended magnet, it always aligns towards north-south direction. Okay, now so here is the complete scenario. Listen, you cannot ignore this topic of this or activity of this chapter. It is very important. Now, so a small device called magnetic compass was developed in the olden days for finding the direction. So now it has a magnet in the shape of needle which can rotate freely. Just you can see here, this is the whole scenario, and the needle of the magnetic compass indicates the north-south direction. So question is that, sir, if this is the compass, this needle, this red portion is basically north pole and this is known as south pole. Now from this we can find the direction. And this, remember, this needle is also a magnetic material, means a compass. It is also magnet. So it must be made of magnetic material as well. Now the compass is kept at the place where we wish to find or know the direction. After some time, the needle comes to rest in the north-south direction. The compass box is then gently rotated until the north-south direction mark on the dials are aligned. Okay, just you need to rotate the compass so that it is aligned towards north-south direction with the needle. Now all the directions at the place as indicated on the dial. Now here we have the directions that it is indicated, that is north pole, south pole, west, east, northeast, southeast, southwest and northwest. All these are given here with the degree as well. So from this activity we conclude that a freely suspended magnet always aligns towards north direction and it is used to give direction. A magnetic compass is A magnetic compass is usually a small circular box with a transparent cover on it. The magnet in the shape of needle is mounted on a pin standing on the bottom of the box, and this needle is balanced on the pin in such a manner that it can move around this point easily, and that is, it can rotate freely. Okay, simple that the ends of the needle which rest or in the north south directions usually pointed red. Okay, north के लिए red use करते हैं. Below the needle there is a dial with the directions mark on it. So it is the explanation of this dial. This is called dial, and the above it is given all the marks. Okay, so here you can see that Resma is thinking that how to make our own magnetic compass. So you can easily make compass by just putting a iron nail over a pointed object so that it can easily rotate and you will get the directions. So hope you will got at this point we have learned something important. First we have learned about what is magnet. We have learned poles of materials, magnetic or non-magnetic. We have learned south pole, north pole. We have learned directions. So all these things we have learned about the magnets. Now the next activity 4.4 it explains. So next point is activity 4.4. Let us construct. So what we need to construct, just be careful. Collect a few materials like cork piece, iron swings, needle, permanent bar magnet, a glass bowl, and water. So here we are going to make a magnetic compass. Place the iron swing needle on the wooden table, then keep any one pole of the magnet on the one end of the needle. Move the magnet over the needle along its length and shown the figure. So just listen. Just here, this is the needle. Now take a bar magnet and just move the bar magnet from this side to this side, and again just bring it here again. Repeat this activity several times. What reaches the other end of the needle, lift it up, and then again repeat this. Now bring the same pole of the magnet you started with to the same end of the swing needle from which you can begin. Now repeat the previous step. Repeat this process at least 30 to 40 times, and you will see that this needle become a magnet. It will behave as a magnet. So we made this needle a magnet. Now the rest story is with you. Okay, so what we will do next? Nothing, simple, very simple. Bring some iron filings or steel pins near the magnet. If these pins or iron filings get attracted to the needle, then that means that the needle has become a magnet. So finally it will become a magnet. Now just see here. Now pass this needle through a cork horizontally. Float the cork on the glass filled with the water such that the needle always remains above the level of water as shown in the figure. Very simple. आपको cork के अंदर ऐसे ऐसे needle को pass कर देना है and just place over the water. Now when the needle come to rest, your magnetic compass is ready for the use. Note the direction in which the either side the magnets pointed. Okay, here listen. Here in this case, nothing mentioned which one is north pole, which one is south pole. So no worry. Just keep it to the rest, and by using the direction method, if it is east, this is west, this is north, this is south. So it is towards north, this will be north pole, and this will be your south pole. Simply we can just calculate and write the names or color it with a paint. Rotate the cork gently and wet till it stops rotating. Repeat this activity few more times. Do the ends of the needle always pointed in the same direction. The answer is yes. Do the ends of the needle always pointed in the same direction? The answer is yes. So from here, see what we have learned. We have learned much before the whispered use of modern magnetic compass, a device similar to the compass needle made by you was used by Indians for the navigation at the sea. It consists of magnetized fish-shaped iron piece kept in a vessel of oil. It was called Matsyatra or Manch-yatra. What happens when we bring two magnets close to each other? Okay, so the next question is that suppose that you are asked to bring two magnets. Suppose that one magnet is this, north pole, south pole, and other magnet is here also. It is mark north pole, south pole. Okay, mark number 2, 1. So when these two magnets are bring close to each other, so what will be the scenario that we need to discuss? Either. So the next activity is 4.4, attraction and repulsion between two magnets. So the 4.4 activity will discuss about the attraction and repulsion between the two magnets. So let's start the activity 4.5. Take a pair of bar magnet on which north and the south poles have been marked. Now mark the two bar magnets as A and B. So we'll take two bar magnets A and B. North pole, south pole must be mentioned over it. Place the longer side of the magnet over A over 5, 4, 6 round shaped pencils as shown in the figure. Okay, let me explain you with the figure only first, so we'll just understood this concept. This is the scenario. Okay, this is the scenario. First, you can see here, this is the magnet, and it is placed over round shaped pencils. Okay, scenario number 2, round shaped pencils, but this time the pole is changed in this case. In the first activity, we are just trying to bring the two different poles together, and the second activity we have tried to bring two similar poles together. So what will we learn here? Just we go through the activity. Okay. Now bring one end of the bar magnet B near the ends of the magnet A placed on the pencil. Make sure that two magnets do not touch each other. Observe what will happen. Okay, so you just remember, it will just bring these two close, but try that they do not touch each other. You will see here, this compass will try to move this side. So what is this? This is basically attraction. What is this? This is attraction. Okay, attraction. Now remember attraction. Why? Because we are placing two different poles, north south together, या फिर south north together. Next. Now next, bring the other end of the magnet B near the same end of magnet A. Same end A. Here, see, we can see here. Now, does the magnet A on the pencil begins to move? Does it always move in the direction of the appearing or approaching magnet? What does this observation suggest? So what is the session here? Listen. So we can see here, you will see that unlike poles. What does the meaning of unlike poles of two magnets? Unlike poles means one is either south, north, or north, south. This is the condition. That is, the north pole of the one magnet and the south pole of the other magnet attract each other. So, and the like poles, that is either the north pole or the south pole of both the magnets repel each other. So here we have learned the things that unlike poles attract, like poles repel, and like pole repel or repulsion. So this we have learned from this activity, that unlike poles attract, like poles repel. Now repeat the activity by using iron bars in the place of one of the magnets. Okay, iron bar. We are not using iron. Sorry, bar magnet. We are using an iron bar. Here, what do you observe this time? So here we find that both the ends of the bar magnet will be attracted by both the north and south pole of the magnet. From this activity we found that magnet can be identified by this property of repulsion only. Listen, why repulsion only? Because suppose that you have an magnet, north pole, south pole, and this is an iron bar. In both the cases it will be attracted, either it is south pole or north pole, no matter, it must be attract. So it will be attract. So it proved that this is not a magnet, it is a magnetic material. If it is magnet, if this pole, suppose that it is attracting, so at this pole it must be repulsion, but in both the cases it shows attraction. So we can conclude from this activity that repulsion is the property to identify magnetic materials, okay, or magnets. Now activity number 4.6, let's experiment. Now we'll do an experiment. Here. So what is the experiment here? The experiment is, take a magnetic compass and a bar magnet. Place the magnetic compass over a horizontal surface and wait for its needle to be come at the rest. That is, we are doing from the starting. Now Slowly bring north pole of the bar magnet close to the south or north pole of the magnetic compass and so in the figure. What they need to do? Slowly bring north pole of the bar magnet close to the north pole of the compass. What will see? We will see repulsion. So observe the compass needle carefully. What do you observe? Does the needle deflect? If yes, in which direction? It will deflect. Yes, it will deflect, but in which direction? So for this, just look at here. Okay, just look at here. This is the actual scenario. This is the bar magnet south pole. This is the north pole, and here it is the magnetic compass. This is north pole. This is south pole. When I bring close to it, you can see that if this is north pole, it will go away, repulsion, so it will move like towards this, and if south pole, it will attract. So from here this activity, so that same poles repel again, and here different poles attract. So from this activity we can experiment, or we can say that same pole repel, different pole attract. Now repeat the above setup with the south pole of the bar magnet. Do you observe any difference this time? Yes, we have seen a difference in this time. So what we have seen? We have seen when the north pole of the magnet is brought close to the north pole of the compass needle, it moves away from, as shown in the figure. The compass is moved away, that we have seen in the figure. Now when the south pole of the magnet, is brought closer to the north pole of the compass, it moves closer. Simple attraction and repulsion. So suppose we place a piece of wood between a compass needle and the magnet. Will this affect the deflection of the needle? Please tell me the answer of this question in the comment box. For yes, you will just write yes, and for no, you will write no. No explanation. If you give explanation, it is correct. So here is the activity. Now let's investigate. First we have done the experiment. Now it is time to investigate. So what we have done here, that this is the compass, this is the magnet, and in between we have placed a wood. Now what effect? Compass needle and magnet with the piece of wood in between them. Repeat this first or second part of the activity 4.6 without disturbing the bar magnet and magnetic compass. Place the piece of wood in between them, perpendicular to the table as shown in the figure. Observe the compass needle carefully. What will we observe? We will observe that there is no effect. The compass will rotate or deflect in the same manner like previous one. Is there any effect? On the needle of the compass due to the presence of wood? Record your observation in the table 4.2. Repeat this process by replacing the piece of wood by a cardboard sheet, thin plastic sheet, and thin glass sheet. Okay, so you will just record your data here. Then you use wood. What you will observe? Suppose that you are observing that no change occur. Cardboard, no change occur. plastic, no change occur. Glass, suppose that you were just writing this, okay. Now it may be yes or also as well. So you would observe that there is no appreciable change in the deflection bundle when a sheet of any of the above is placed between the magnet and the compass. So what we have observed here, if you place wood between the compass and the needle, if you place cardboard, if you place plastic, if you place glass, there is a very very small change, that is, and no appreciable change. So what we conclude? We conclude here that magnetic effect can act through non-magnetic material as well. What we have concluded here, magnetic effect can be felt, can be act through non-magnetic material, or we can also say that a non-magnetic material cannot affect the magnetic field. Okay, we can also say that non-magnetic material cannot affect the magnetic field of the magnet or the strength of the magnet. Now, fun with the magnet. The next topic is fun with the magnet. After learning about the magnet, Resma was very excited and decided to set up a fun activity using magnets at her school fair. You may try making this yourself and may also think of some of the more fun ideas. So, can we make a garland? Yes, we can make a garland like this. It is very simple. What we need to do, you just take a bar magnet as shown in the figure. Just take a bar magnet and some iron clips, and place. It will join as like this. So become a garland. Magnets can move some objects without touching them. Is it not amazing? Yes. Suppose, for example, suppose that this is a magnet, south pole, north pole, and if I'll bring a magnet here, south pole and north pole, just bring close, this will move this side, or if you just bring this to here, this will move this side. So without touching, this can move. Yes, it is very amazing and it is very interesting activity. So I hope these things are very clear to all of you. Now we'll here play an activity. It is very interesting game as well. You can say that fun with the game. So what we need to do is simple. You can see here, steel balls in the maze or steel paper clips in water. Okay, now can we take out the steel balls out of this maze? Moving magnet below the cardboard tray. Yes, what we need to do, just place a magnet below this cardboard, and you can just bring it out from this maze. Okay, so first below this you will just bring out from here, you can just bring out here, this one here, this is bring out from here, this one or this one. Okay, from here you can just bring it out, this one from here, again from here, and this one, yes, from here or from here. It is very simple, or from here it is very simple. So we can just bring it out. Can we pick up out a steel paper clips fallen in the water using a magnet without making our finger the magnet wet? Yes, it is possible. Take a bar magnet, just place over there, it will attract and just pull it down up. So easily it can be. So these are the fun activity that we need to do at the home, and this is also a fun activity. You can make a very simple activity is that very simple. आप घर पे कर सकते हो. Will two cars speed towards each other? or run away from each other closer. कुछ नहीं करना है. Place some wheels here. Match stick. If both the poles are same pole, they will go along this side. If the poles are different, they will come this side. So very simple. Two match boxes, magnet card with the like poles approaching each other. Okay. Now, in some magnets, North pole and south poles are marked N and S. In some other magnets, the north pole is indicated by a white dot. Sometimes the north pole of a magnet is painted red and south pole is painted blue. So that I have clearly asked you one thing. You remember this? If it is a bar magnet, this is your north pole, this is your south pole. So it is not necessary that it will always retain south pole, north pole. This point may be blue. This point may be as a white dot here. So we don't have a white color. White color kya? Just assume it a white color. Okay, option is there white. So just do a white here. So simple. It is very simple. Okay, you can do this activity at the home without any difficulties. Next. So I hope all these things are very clear to all of you. Now this time we are going to discuss how to make safe our magnet, how to keep safe the magnet. You can see here the magnet is placed inside a box, and this is one magnet, this is other magnet. In between them there is a wood. Iron piece if you put iron piece or wood, which one is possible? And this side, this is iron piece. Why? Listen, magnet says, store me properly, keep me in pair with like poles on the same side, keep a piece of wood between them, place two pieces of soft iron across the two ends. Do not drop me do not drop or hit me or drop me or hammer me. Okay, why? Because all these things will destroy the magnet and its magnetic property will be destroyed. So do not keep me near mobile phones or remote controls. All these are the activity, these are the precautions to protect the magnet. Cautions: have fun, but treat magnet with the care. So from these activities we know how to keep our magnet safe. First, keep them opposite poles with the iron piece. In between them there should be a wooden frame or wood. Don't hit it, hammer it or drop it. Dropping can also destroy the magnetic property. Hitting can also destroy, and hammering can also destroy. So all these are the points through which the magnet property can be lost. So these are, so at the last we are here. This much we have discussed today. So in a very concise manner I am going to discuss the things at the last, keywords what we have discussed here. Listen, attraction, conclude, bar magnet we have constructed, magnetic compass we have done an experiment, magnetic materials explore, non-magnetic materials investigate, north pole of the magnet we have observed it through the activity, repulsion, prediction we have done through the activity, ring magnet we have record the data Okay, so all these things, and south pole and north pole we have also. So these are the things that we have discussed in this whole chapter today. Okay, so now some questions will be there. If you have any doubt, any query about these things, please feel free to comment below the comment, and please give your suggestion how you like this session. I hope and make you understood each and every concept, each and every activity with a great understanding. Hope you like this video. Will share with your friends, and listen. Whenever you're going to learn this chapter, be very patient. Thank you. Have a good day.